Start with the new class that's about interfaces and inheritance, how interfaces are going to be implemented, how they're different from classes, and what extra benefit that you are getting in interfaces, that we will discuss today. Okay, so we have created a project and we're going to define a class in that project, or we can reuse the last project's classes also, and we can see how interface is going to help us in that area. Okay, so in the last project we had one example of a shape class. You remember that? So where is that? Inheritance Java class one, right? This is the project which we had discussed, and in this project we learned how Java classes are extended in another classes, and how the behavior of a class is extended, how the behavior of a class varies if we extend one class in another class, right? So basically extend means like extending the behavior, extending the capability of a method, of a class, or of an entity. Okay, so what class, the super class that we had is called shape. Shape is a class which is having a method which we call calculate area. This method doesn't know how the area calculation is going to be taken place, and if the shape is a circle, then circle knows how it is going to calculate its area. But if you are considering a shape, suppose I want to I just tell you I have a shape, I have a shape object. Can you tell me the area of that object? You cannot tell that because you don't know what type of shape is that, right? If I'm going to ask you, I have a rectangle and I have the length and breadth and everything ready. Can you give me the area? Then yes, in rectangle you know the behavior of rectangle, how the area is going to be calculated. But if you are talking about the super class, if you are talking about some abstract entity, if you are not like sure about the behavior, you cannot say that, right? So in these scenarios, basically used to find interfaces in such scenario. The interface is something which doesn't have the body, which doesn't know how to like give the implementation, which doesn't know how the thing is like going to take place, right? So we'll have an interface of shape. So shape interface is going to have this method calculate area. So interface is setting a rule. It's going to set certain criteria, it's going to set certain protocols in the market, in for all the shapes available in market. So any shape that is going to have its existence, that is going to implement this interface, right? So this interface is going to have this method calculate area without any body. So this interface won't have anything in that in the method body. So basically interfaces are the collections of methods which don't have any body. It just have the like the definite, the structure of the method. It doesn't have the body of that method. So let's create one interface in our newly created project. So let's rename it to uh, inheritance in Java with interfaces. So this is the project that we have created now, and we're going to create a new class. We're not going to create a class now, we're going to create an interface. So this is interface, and we're going to define the package name com dot say suppose inheritance dot business object. Now we're going to call it shape interface. Now this is how you're going to define an interface. It just has the name interface, which you have class for classes. Now you have this, you have defined, you have created an interface. Now the shape interface is saying that any shape in the market, any shape is going to be created, that is going to have one method, that is calculate area. So you are going to define calculate area. So this is the method that all the shapes are going to have, but this method structure is not yet ready. This method returns a type. So this, suppose this method is going to return you uh, a float type data. So you're going to give the return type float, then the method name and the values, like the variable, the method parameters that you want to pass over here. Suppose I don't want to pass anything, I just created the interface. Now what I'm going to do, I'm going to create two implementations of that interface. So one implementation that is called a circle, and that's a class. So I'm going to create a class named circle that's going to that's going to extend the behavior, that's going to implement what interface didn't have. So let's create the circle object first. So this is the circle object. It's going to implement the shape interface methods. The shape, it just says you will have to you'll have to calculate the area. Okay, but this shape interface, it doesn't know how to calculate the area. Now circle says I am going to implement what the shape interface says, what the shape interface has like given the criteria. So now this implements, and you are going to write shape. So this shape interface is going to be implemented by circle. So whatever methods you had in this shape interface, you need to define them over here. So you can see an error over here. So basically you are going to implement those methods. So it is saying add unimplemented methods. You can click on that, and then you can see it's giving the annotation as override. So basically it's saying that this method is derived, or this method is implemented, or this is extended from a superclass. So let's do one thing. Let's calculate the area. So this is the circle classes like representation, how we're going to represent the things in circle class. The circle class will have a constructor, so that constructor is called circle constructor, and its circle has a property that's called radius private, and it's going to be a float radius. Okay, and you are going to pass radius, that's float radius, into this circle object, and it's going to set this dot radius equal to the radius that it has received. So now this circle, whenever somebody is creating this circle object, it is mandatory to pass a radius. Now the radius is created. Now the person is calling, the client is trying to like calculate the area. So they are going to call this calculate area method. So this calculate area method will actually have the implementation, the logic to calculate the area. So we know how we are going to calculate area. So we are defining a variable float area equals to, now we 3.14, that's pi, into radius square. So that's radius. So now we have created okay, this is going to be float. Fine, we have the area. Now we are going to return that area to the caller, whoever is calling us. So we can save the class. Now this class is an implementation, this circle is an implementation of a shape. So whatever shape you are going to create, like you have created circle, it is mandatory to have this calculate area method. Suppose I want to create a rectangle now. Suppose let's create a rectangle class. Now this is going to be a part of this this is going to be like this is going to implement the shape interface. Suppose I'm going to call it rectangle, right? Then I'm going to add the interface. You can do this way also in Eclipse. You can directly, here is the interface box, you can add the interface, you can write the name of the interface, that is shape. So there are two shapes available. Don't go for the java.aw2, go to the interface that you have created recently inside inheritance java with interface project. And this is the package structure inheritance.bo, and shape is an interface, so you can see an I sign before that. So I'm going to implement shape interface. Okay, now the shape interface is over here. Now we are creating a new class that's called rectangle. It's implementing shape interface. Let's finish. You can see the method is automatically like displayed over here. You can so every rectangle, they have two things, two variables or two fields in them that are called the length and breadth. They're going to be of type float length and private float breadth. So you have two variables or two fields or two parameters of the rectangle object. So this rectangle shape is going to have two parameters, and you are going to create a constructor. So this is going to be the constructor where you are going to set the values float length, similarly float breadth. So you're going to set the values this dot length equal to length, this dot breadth equal to breadth. Now the values are set. Now what we are going to do, we are going to calculate the area. Similarly, like we had created the area of circle, we are going to do the same way, but this is going to be 0.5 into base into height. No, the rectangle area is called breadth into height, right? Breadth into height, length, sorry, whatever it is, length. Fine, now the area is calculated and I'm going to return the area to the caller. Fine, now I have two classes, two complete classes. One is called a circle, one is called a rectangle, and both of them are implementing SAP interface. You can see both the classes have the similar structure and they are having this method called calculate area, which is defined in the SAP interface. So let's do one thing, let's create a test method so that we can test. So let's go change the package name and it's going to be inheritance.test and interface test. I can call it interface test. Now this method is created. I'm going to create a main method. This is going to create the objects of circle. So this is how you create a circle object. Circle equals to new circle, and you are going to pass the radius like 1.12.3, and this is going to be float value. Now you have created, see, these are two different packages, com.inheritance.test and this rectangle or circle, they are into com.inheritance.bo. So what you need to do, you need to import that. You can use this way, import circle inheritance.bo. Now the circle is imported. Now you have the circle object ready. Now what I want to do is I want to print the area of circle. Area of circle is plus circle dot calculate area. Fine. This calculate area is coming from interface save, but it's going to be implemented inside circle. Let's run this and let's see the output. Of course, I don't know the area. Let's see how it is calculating for 70 points. So this is the value. This is the implementation inside circle class, right? It's not executing within SAP interface. It's implemented within circle class. Similarly, we can create a rectangle and we can see the output. See, this is going to be a rectangle. Rectangle. Where are you? Rectangle. Rectangle equal to new rectangle, right? And we need to pass two values, right? One length and one breadth. So let's create a simple one, 2 length and it's equals 3 as the breadth. Now I have created a new rectangle, but it's showing some error. What is this? Float is undefined. So did I create the rectangle object as float and float? Yes. What is the problem? Did I? Okay. See, the problem that we generally face in Eclipse is the import, that is wrong import, right? See the rectangle that is highlighted, that is imported from java.awt package, right? But we don't want that, right? We want the rectangle from our package, that's com.inheritance.bo package, right? So you can either write the same thing over here, or you can use the Eclipse way of importing. You can use this thing, import rectangle. See, both the options are there. We need to choose our object. Now this is fine. Now we have created two objects. Area of rectangle is rectangle dot calculate area. So this is going to like calculate the area of the rectangle. Area of rectangle is 6. So you can see 2 into 3, that is 6. We don't need these zeros over here. Fine. So this is how the shape interface has imposed that any shape that is going to take place, that is going to have this method, and the method structure is that whoever is going to calculate the area, that is going to return the area back, and that return area type is going to be a float type. So this is the structure, this is the syntax that SAP interface has laid out. SAP interface has already said this is the protocol. So everybody is going to return a float type, every calculate area method, right? Suppose in this case, okay, go on. If you have any questions, just ask me. Fine, right? So you had some doubt of overloading and overriding, right? You remember that? Okay. So when you talk about interfaces, right, or like classes and their implementations, like extension or implementation of interfaces. When you have these things into picture, when you have inheritance into picture, the type of the object, right, the type of the object, that can be a class, that can be a circle, that can be a rectangle. So these types, if these types are defined, if these types are like uh, defined in the runtime, okay, if they are defined in the runtime, the method that is going to be called, that is going to vary. So if now we have shape interface and we have two different classes, rectangle and circle, which are implementing shape interface. Let me show you one example. In that example, you are going to use the shape interface reference interface test. Let me create another class, interface face test with overriding. Okay, this is going to show you the demo of overriding. So we'll have this method over there, copy to this. Okay, let's go to this method and this class, and I'm printing it over here. Fine. So what is happening when you have the hierarchy arch? uh, there is a super class or an interface, then there are child classes or like classes which are implementing the interface or extending the class. The parent class reference can be used. So this is how we are creating the object. This is how we are creating the object, new circle, new rectangle, and we are putting that reference into a type of the same object, right? You can see we are putting the rectangle value into rectangle, we are putting the circle object like reference into a circle reference. So if you want to show you how like overriding works, I can take the super class. So what I have, the super class is shape interface. So I can create a reference of shape and still I can hold the value of its child classes. So I'm going to create a shape reference. Shape is an interface. Let's import that. I have pressed control and shape, control and space. It's showing me to import shape from com.inheritance.bo. I've imported that. Now the shape reference name equal to, I cannot create new shape because it doesn't, this shape interface, they don't have a body, right? They don't have the definition of constructors. So these shape interfaces, they cannot be instantiated, right? This is not going to work. So what I'm going to do, I'm going to create a circle, or I'm going to create a rectangle, and I'm going to assign that object's reference to this shape. So a circle is a shape, right? So this is how it is working. A circle, it's a shape. So you can assign the value, the reference of the circle into a shape reference, shape variable, right? Shape interface is going to hold the circle object because it can hold. It's the super class. It's the super implementation. It's the interface, right? Now I can call the shape method, shape class, shape interface dot calculate area method, right? Suppose somebody doesn't know, like somebody just knows that he has a shape reference, and is going to call the calculate area on that shape reference, right? So suppose he doesn't know which implementation is there. It can be a circle, it can be a rectangle, whatever it is, right? Then this shape is hiding the behavior, like hiding the implementation from the user. But so if you control and click on calculate area, it is going to take you inside the shape interface, right? Inside shape interface calculate area method. But the object that was created, the circle object that was created, that object's calculate area method is going to be called because we have assigned the object, the circle object, into this reference. So this is dynamically like it is overriding the behavior of shape interfaces calculate method, and it is calling the behavior of circle objects. Okay, circle superclass or circle objects calculate area method. So if you try to run this, you will get to know that this is calling the this is calling not the shape interfaces calculate area, it's calling the circles calculate area. So let's circle 2 is shape dot calculate area. Fine. So we are calling the interface we are calling the interface method, but a class method implementation is called. That's what we called overriding. So let's run this code, Java application. You can see area of circle is 16.06, and this time this has called. So if you want to see actually if it is calling that one, you can use a debug mechanism of Java, which I have already shown you how you can debug. You can comment out the code which you don't want, star, and then you can run the rest of the code. Now we have the shape interface and we are calling it. So let's do one thing. Let's put a debug in the circles implementation of calculate area, and let's debug this class. Right click, debug as Java application. You can see this method is going to take us into the circle class, not the shape interface. See, now I have debugged and I am inside the circle class, right? But what method was called over here? It was calling to shape dot calculate area, but it called the implementation, shapes implementation, that was the circle implementations class. Right now we are in this line, and when we went into the circle, now it's here, right, in the circle class. So you can remove the debug if you want, you can release the debug now. Okay, so this is how the overriding works. This is how interface is different from a class, right? And there is one more rule in Java. So basically there are two things you must remember in inheritance. One is extending the behavior of something which was already there, which already had the existence, right? That's what we call extending, right? So for a class, if the class has a method or has a body or has some sort of variable, some references, you are creating a child class, you are creating another class which is extending the parent class, then basically you are extending the behavior, you are extending what the parent class was doing, and you are doing something more than that. But if you are going to implementation like you had in interface, they didn't have anything. They just had the rules ready. They just had the structure ready. You just need to put the code. You just need to implement the logic. So interface just said you need to calculate the area and you need to return the value, float value, right? But here is the implementation, how you are doing it. So this is what implements is. So when you are talking about implementation, then you are going to do something new. You are going to implement something. But when you are talking about inheritance, when you are talking about extending, then you must remember that there is something already. You just need to extend, you just need to add some more behavior, some more facility to that. So this is just basically the difference between what we call extending the behavior and implementing the behavior. So if you have classes and you want to create one more class, you can extend the previous class. If you have one interface and you are going to create a class out of that interface, then you are basically implementing that interface. Similarly, if you have two interfaces, first interface is going to extend the behavior of second interface, because both the interfaces, they don't have any behavior, right? They just don't have any existence. First interface is created. Suppose, let me show you one example over here, how the two interfaces, they are extending each other. I'm going to create a new class. Suppose this class is called com.inheritance.interface test. Suppose we're going to call, suppose I'm going to create a vehicle. This is going to be the parent interface. Okay, the vehicle interface, this is not a class, this is going to be an interface. So what I need to modify, I need to modify this interface. This is a vehicle interface, right? So the vehicle interface will, so see how you're going to segregate that. You're going to have a vehicle interface, then you have different types of vehicles. Suppose I'm going to create another interface, right, which is called bus. Bus is a vehicle, right? But there are different types of, suppose I'm going to create a car. Car is a vehicle, but there are different types of car. A car can be a sedan, a hatchback can be there. So there are different types of car. So basically what I am doing, whatever rules vehicle has already created, that I am going to streamline, for a particular type. Suppose I have a vehicle, so it's going to have a method public. It's going to return int number of wheels. So this is one method which is going to be there in all the vehicles in the world, right? So this method, it can say get number of wheels. This is the method name, right? Every vehicle is going to have that. Suppose I want to specify that I'm going to create a car vehicle, right? So that car, that interface car, so I'm going to create car interface that is going to extend the interface vehicle. Okay, so it is the car object or the car interface is going to have the number of wheels method as well as some specific methods which belong to the car. Suppose let's create, let's give one more type, one more behavior to this car. So what is one specific behavior of the car interface that a car used to have? Okay, go on. Suppose a particular type of behavior that a car has, but a bus doesn't have, a bike it doesn't have. What type of thing that you can have in a car? Okay, sunroofs, because you don't find sunroofs on bus, you don't find sunroof on trucks, right? You don't find sunroof on on bikes. So is sunroof available, right? So maybe we can define boolean. It's going to be return type is available. Is sunroof available? So this is going to be, so if this method is called, and this method can be called only upon a car, it's not going to be called on a bus. So this is the behavior that I'm extending. So you can see this interface car is extending another interface vehicle, right? So this is how the interfaces, they extend the behavior. So once you have defined the car, you can define another interface that is going to be a bike. Suppose I'm going to define a bike. So this bike, it needs to extend the behavior, extends the behavior of vehicle. So vehicle, so you are basically extending the behavior of a vehicle in an interface that's called bike. So the bike, so even this bike interface is going to call the vehicles get number of wheels. So this bike is going to always return 2, right? So you don't need to specify, you don't need to implement that over here. So when you define, when you create a bike, suppose Yamaha bike, then you can define like you can return the value, the number of wheels that you have in Yamaha bike. So this bike is extending the vehicles, the vehicle. So what we can have in bike is a specific type of a specific what do we call it, behavior of bike which is not there in car. Go on. Sorry, don't know anything. Do you ride scooty?
No,
Yes, you ride scooty. So just tell me one behavior of scooty which you don't have in car.
I don't like it.
You don't drive scooty, so at least you would have seen a scooty and a car.
Yeah.
Okay.
In fact,
Sorry. Kickstart.
gear not there in
Sorry.
some cities. Gear is not there in some cities.
Gear is not there in scooties, right? So is gear available? We can have one method which is called is gear available. But that what we call it, that behavior is also available in car also. Cars can also have the gears. We call it shift. Cars also, they have the shifts, right? So you mean to say every bike and scooty, they're equivalent to cars? Even I have started thinking, what is the difference? Come on. Okay, so let's just give one something which doesn't make any sense, but let's, to complete our method we have to do something,
Can
right?
change it.
Sorry.
You can change the interface.
Oh, I can't hear you. Get number of this. You can change the name of interface to train. Oh no, not going to make any sense. Train, that's a static, like that's a class, that's an complete class. You don't have any segregation in trains. And train, nobody calls a train a vehicle. Come on, do you call train a vehicle? That's not going to fit here, right?
No.
You can never call train. And I know in Marathali there is a train line which is going in between, right? I went there. It used to be a lot of traffic when a train used to come there. Right? Okay, so we're not able to find any difference from a bike and in a bike and a car. So in bike, what we can say is number of riders, like number of each pillion available. So some bikes in this, like nowadays used to have, you can see some bikes which is going to have just one seat, like only the rider who is going to ride the bike, he can sit. So pillion is not available, right? So number of, like we can create a method which is going to return an integer, because I can't, there can't be 1.5 person, there has to be 1 or 2 person. So it's going to be an integer type. Int get number of pillions. Pillions is the, like the person who is to sit behind. So we can number of riders, whatever we want to say. So this is the rule. So this is the rule which this bike is extending that the vehicle doesn't have, right? So you can actually make some, you can actually put some method over here which is going to make some sense. I just made this out. So this is how the interface can extend the interface that is already created. Now let's create a new class, and suppose you want to say that you want to create a Yamaha bike. So this is a class, right? Interface test, but this class is actually an implementation. This is not extension anymore. This is actually implementation, because there is no bike already created. I'm going to create a new bike, Yamaha bike. I'm creating a complete thing. I'm not creating like I'm not extending the behavior. I'm just creating the bike. So interface just implementation. Okay, Yamaha bike. Now I'm creating the Yamaha bike, but it is going to implement which one? It's going to implement bike. It can implement car, but if you implement bike, it's going to make sense, right? It's this is going to get the behavior of bike as well as the behavior of vehicle. So let's implement bike, and let's implement, sorry, undo. Let's implements bike, and let's import all the methods of bike as well as shape. You can see, okay, let's save it, and then it will ask me to animal. You can see both the methods are imported over here. One second, you can see both the methods are imported, right? One method from number of wheels, that is from truck, right? So I'm going to return here 2 if it's a bike, and number of pillions if this Yamaha bike is, it just actually has one person who can sit behind. It's going to return 1. That's only one person can see, right? Suppose I'm going to create a new class, and that's going to, how these implementations can be different. I'm going to create a splendor plus bike. Okay, I think you will help me out with this implementation. Implements bike, right? And I'm going to add the unimplemented method. Number of wheels, it is always 2. Bikes, they don't have more wheels. But do you think the number of pillions is going to be 1? I think it's going to be n, anything you can write. So at least in Splendor Plus, I have seen people saying like 3-4 people they used to pass. So at least this Splendor Plus, it has 2 pillions, like 2 people can sit behind the rider. So this is how the implementations, they actually vary. So you have the vehicle interface at top, which is defining just one rule for all the types of vehicles. Then you have a car which is defining all the rules for a car as well as the vehicle, because any car, that's a vehicle. Any bike, suppose Yamaha bike, that's a bike as well as a car. Splendor Plus bike, that's a bike as well as a car, sorry, as well as a vehicle. So this is the hierarchy. Every vehicle that what do you call, the rules that vehicle interface has created is going to be extended in bike. Along with vehicles rules, I'm going to add this one rule. So this is how the interfaces and classes work. So if you have any more question about interfaces, how they different from classes, you can just, or you can always ask me the questions. I have made a spelling mistake. Let's rectify that, refactor and rename. Splendor. Fine. That's done. So questions. I think I'm teaching well. You don't have any questions. Come on.
So why the need of interface
Why?
when we have an inheritance? What is the need of
Interfaces in,
interface?
right. What
When
is
we
the need
already
of
have an inheritance.
interfaces? Okay. Uh, suppose what happens, like you're going to create a library, right? You're going to create some sort of utilities, but you don't know the implementation, right? One good example is in Java. You have some packages, you have some classes and some interfaces, some sort of library that is called a database library. We call it JDBC in Java. Okay, Java Database Connectivity. What Java has done is Java has created this library that is full of interfaces. 5 minutes. That's full of interfaces. Okay, this library is full of interfaces with methods which is going to connect to database, which is going to fetch records and all these things. So these are the things which is going to take place in market, but Java never knew how Oracle is going to do that. Java never knew how MySQL is going to do that. So basically Java has created the library with interfaces. So that interfaces will have methods like connect to database, okay, fetch me a record. So these are the interfaces which are present in JDBC library that is available with Java. Now Oracle has come into market, tomorrow MySQL has come into market, now lots of database vendors have come into market. They have taken that interface from Java JDBC and they have written their own implementation, right? When we need to connect to Oracle, we are going to use Oracle's classes. When we are going to use MySQL, we are going to connect to MySQL database. So that implementation is different, but the rules, set of rules, that is always going to be constant. So that is how interface will help you. When you are going to create some library, when you are going to create some sort of like set of rules, we are going to like give that rule into the market. You're going to give that rule to clients to implement. At that place, you need to have interfaces. When you study like some libraries, like Selenium is a good library. When you study Selenium, you will get to know lots of interfaces in that. Okay, and how those things are implemented. Any more question?
This is a multiple inheritance of hybrid kind of inheritance that we used to have in C++.
Sorry, multiple inheritance is not there in Java. That was the question. Hello.
Yeah, then how do we
Okay, why multiple inheritance is not there in Java, right?
yes.
Yeah, that's a good question. I just don't want to answer it right now because you just came to know about interfaces. I would like you to do some sort of like assignments and interfaces first. Then you try to learn how, why this thing is not there in Java. You can always Google and you can find lots of answers, but try to do it on your own. Try to find out why multiple is not there, right? So try to recall how multiple inheritance used to work. Then try to find out why this is not there in Java or what problem could have happened if that is not there in Java. Then I'll define that. I'll try to explain that in your next class. If you can't answer, if you can tell me, that is going to be very fine. If I want to add something, I'll tell you in the next class. Okay. Any more questions? No.
Yeah, that, no, not really.